complex real-world problems. Now, solving real-world problems requires complex workflows with multiple steps. What agents do is they use LLMs to first create a multi-step plan to solve a real-world problem. So, for instance, consider a conversational shopping scenario where the user asks the agent to show the best Android phones for recording TikTok videos. And, the agent creates this plan to solve a recommendation task that involves three steps that are shown here. First step is to retrieve relevant snippets containing requirements for phones to record TikTok videos from the knowledge store. The second step is really to extract the phone specs, like things like the processor or camera from the retrieved snippets. And the final step is to invoke a product search engine, with the extracted phone specs to retrieve a ranked list of phones, right? So, this is the plan that the agent creates using LLMs. And the next step after the plan has been created is to execute each step of the plan by invoking appropriate tools to solve the overall problem. And these tools can be external tools, right? It could be like a product search engine and so on. So let's trace the execution of the plan created earlier by the agent to recommend phones to record TikTok videos. So here in the first step, the agent has retrieved this snippet that contains requirements for phones to record TikTok videos, and this is sort of retrieved from the knowledge store. In the second step, the agent goes ahead and extracts the phone specs from the retrieved snippets. So this is 2 GB of RAM and 12 megapixel camera resolution. And in the final step, the agent invokes the product search engine, and with the search query shown here: Android phone, 2 GB RAM, 12 megapixel camera resolution. And you can see that the product search engine has retrieved these different phones and rank them in the order of relevance. Right now, agentic computing paradigm is really catching on in a big way. And any conversational engine out there that you're interacting with are using agentic computing to answer user questions, to do interact with users, and in general solve complex problems, right? Now, moving to the second part of my talk around LLM applications that we have developed at Amazon, right? So the LLM applications we've built can be classified into three categories based on applications for improving customer experience. We have built applications for improving seller experience, and there are applications that we built to improve catalog quality, right? Now, one of the big launches we had last year was the Rufus conversational shopping assistant, which we launched in the US, and we also launched it in India. And for the India launch, my team did a bunch of things. We improved Rufus's appearance to respond in English, which is the code mixed language of Hindi and English for English questions. And we also ensured that Rufus provides safe and precise responses as per the guidelines that we had for India. And we've been able to achieve pretty high compliance rates and so on. Now, Rufus is very similar to an offline shopkeeper. It answers questions that product related questions that customers may have along their shopping journey. So, for example, on this slide, the customer asks Rufus, TikTok videos record करने के लिए क्या phone specs होने चाहिए. So this is a English query, which means, what are the phone's product specs required to record TikTok videos? And then you can see Rufus has, responded in English, right, to the English question, as opposed to responding in Hindi or English. It actually chooses the same kind of language, which is this code mix language, to respond to the user question, and it goes ahead and identifies a Snapdragon processor, a 12 megapixel camera, 2 GB of RAM as some of the product specs for recording TikTok videos. And it also goes one step further and recommends, the Samsung Galaxy M32 and the Oppo A76 as good phones for recording TikTok videos. And then, at the end, you can see that there are some related questions that are shown to the user, that the user can tap on to continue the conversation. And you can see those related questions are also in English, right? So uh, and Rufus can do recommendations, as you can see here, but it can also do answer product comparison questions. So for example, a question like, which is better, a Samsung Galaxy M32 or an Oppo A76? Or even factoid questions like, what is the battery life of a Samsung a Galaxy M32 series, right? So Rufus is a pretty powerful conversational assistant that can help customers, find the product that they're looking for and answer their questions, product-related questions. We also built, an LLM-powered troubleshooting chatbot to resolve customer issues post-purchase. Thus, this is something that helps us reduce return rates. So, customers, after purchasing a product, are anxious and have questions like, where is my delivery? They also have questions about product setup. So for example, how do I install Microsoft Office on my laptop? Or questions about the product not working, right? My air fryer is not heating. So here's a video of our troubleshooting chatbot in action. So let's see. I hope the voice comes through.
I don't think the voice is coming through, Rajiv. It's only the we can see the the
Okay,
chat getting typed.
okay. I'll try to talk about what's going on. So the customer said that their earbuds are not pairing with their laptop, and their chatbots come back and ask to, uh, just confirming the issue. And then, the chatbot's asking the user what kind of operating system uh, that the user uses to kind of get, narrow down the problem, uh, and so on. And now it's the chatbot's giving some suggestions to the customer on, perhaps removing uh, and resetting the earbuds. And now it's giving three other options, because the previous option didn't quite help resolve the issue. So here there are some options given. The customers ask for some more details on how do you clear the Bluetooth pairing history. Uh, and now the chatbot actually gives a step on how to clear the Bluetooth pairing history on the laptop. And so, again, this is an interactive chatbot that, will ask the user questions when, uh, it's not very clear when the situation is ambiguous, like you saw, what is the operating system you're using, because the pairing of the earbuds, resolving that issue depends on the operating system. So the chatbot collects some information from the customer, then it gives some possible ways, different options to resolve the issue. And it keeps, refining those options and also gives more details on steps for each option and so on, right? Until the customer issue is resolved. Um, Now, moving on to, applications that improve seller experience. So one of the pain points for our sellers was that every time they wanted to list a product on Amazon, they had to fill in 150 attributes, values for the product, and this would take almost 2 hours per product, right? So we launched something called a progressive listing experience to simplify the listing experience for sellers. Now, with this, with progressive listing experience, sellers only need to upload an image and a few descriptive keywords of the product, and basically, the LLM in the back end retrieves matching products and uses the metadata to create um, a high quality listing with title, bullet points, description, and structured attributes. Uh, uh, let me show you a video of sort of a prototype of the progressive listing experience that we built last year. So here's a sort of a demo of what the experience looks like for sellers. So here, the user starts, this is seller, uploads an image, enters the brand name, and what's the product type, and that's the only information that's required. And so it starts by clear running some image processing algorithms to clear up the background and so on. And now, using an LLM, uh, the system's generated a bunch of attributes. And the LLM can also generate titles, descriptions, bullet points. So the entire catalog, entire product listing is generated using LLMs here. And this is not just in English. Amazon operates in multiple marketplaces in Brazil and Mexico. So if you want to generate the listing in Portuguese, for example, the LLM can also generate product listings in other languages like Portuguese. So here you can see the title, description, bullet points, all generated in Portuguese. Yeah, so again, this is an example of how LLMs can really simplify processes, right? I mean, here the sellers can just upload an image, give a few keywords like, this is the brand Levi's and it's a shirt, and that's it. And after that, the LLM takes care of generating the entire listing. And finally, I'll talk about a few applications we've developed to improve the catalog quality, right? So
Rajiv, if
Yeah,
I may interrupt, there's a question I thought may relevant for you to maybe
yeah, sure.
answer it.
Go ahead. Yes,
Yeah.
please.
So, question is, what is the average response time of Rufus? Until what time are LLMs considered good?
Yeah, I honestly don't have the current uh, latency numbers for Rufus, but if you're an Amazon user, go onto the Amazon app. Rufus is out there, and you can see. I think it's super fast. Unlike this is our own foundational LLM that we have trained at Amazon, so it is optimized for low latency, right? So you can try that on the Amazon app. It is very fast responses, right? So this is our own homegrown foundational. We aren't using some other publicly available foundational model there, which typically have longer latencies. Many of the foundational models, larger foundational models out there, have latencies anywhere from 5 to 10 seconds, and that's not acceptable for conversational applications, right? I think clearly that's an area that uh, uh, others need to work on. People expect very low latencies here, right? Sub-second latencies, perhaps, right? Would be ideal. So yeah, I would say like just try Rufus on the Amazon app. I don't have the exact numbers, but uh, one of the distinguishing features of Rufus is the low latency. In addition to all the shopping knowledge and expertise in the shopping domain, right? Yeah. Hopefully that
I
answers the question. Yeah.
Another question from the seller experience I just want to ask.
Yeah.
The
Please go
product
ahead.
listing you said is generated through the LLM. How do you validate the accuracy of the description?
Right. No, great question. One of the problems with LLMs, and I'll come to that, is hallucination. And we have a human audits validating the accuracy of the outputs. We have also um, um, we have also been automating a lot of these evaluations. So we have Claude or some other publicly available powerful LLMs also being used to do auto evaluations, right? So clearly, I mean, you look for hallucination in terms of is there information in the that's being generated that wasn't in the inputs that were provided to the LLM, right? And then there are also and I'll talk a little bit more on how we deal with hallucination through prompt engineering, right? By giving explicit instructions to the LLM to stick to facts, that are available to it in the context that's provided and not make up things and so on, right?
Right.
And then the
Okay.
evaluation LLMs also have instructions on, do you see any instances of information that's been provided, that has come in the output that wasn't really in the context that was provided to the LLM and so on, right? So yeah, so that's sort of we use a combination of humans and LLMs to determine if there's hallucination, the accuracy of the descriptions, and so on.
Sure. And all of these happen at the back end before the response is shown to the user, correct? Or is
No, this
generated.
is this application, like some applications, there's no, they happen offline, right? It's not a
Offline.
real
Okay.
time response. I think the Rufus is a real time response. Uh, but the seller experience that I talked about, progressive listening experience, is not real time. It's offline, right? So
Okay.
that happens on the evaluation uh, for every product. that we
Okay.
actually, sorry, the progressive listing experience is also online. You're right. I mean, when people upload the image and the uh, keywords, right?
Right.
Uh, so there is some verification that goes on, and that particular application, perhaps the latency may be a little bit longer. Yeah,
Okay. Got it. All
but
right.
Rufus
Thanks.
is a low latency. Yeah, go ahead.
Sure. Please continue. If there are more questions, I request the attendees
Yeah,
to please type it in the Q&A box and we'll take
yeah.
it up.
Yeah, these are great questions. By the way, there's a lot of work on really hallucination detection and reduction using, self-reflection and, using LLMs themselves to kind of introspect on their answers and I mean, that's what's been happening with many of these advanced models, right? Reasoning models that generate multiple answers and then analyze them and then try to give the to pick the best response and so on. So LLMs themselves do a lot of self-reflection and to try and improve the quality of the answer over multiple iterations. Yeah. But of course, there's one should keep in mind there's a trade-off between accuracy and latency. So the more iterations you do of self-reflection, you're adding to the latency while making your responses accurate. So you've got to find the right balance, right? So let me talk a little bit about work we're doing on improving the catalog quality. So, product summary videos are something that we launched in India in 2020, and they were manually done. They're short 1 to 2 minute videos showcasing key features of a product. These videos aid customers in making purchase decisions by summarizing key product specifications and their benefits in a video format, right? So one thing we found is users don't like to read a ton of text, right? So having these short video snippets that highlight, key features of a product are much more engaging. And we've seen a lift in conversions as a result of that. But, manually creating these videos is expensive. It's over $100 per video. So we came up with some ML techniques to automatically create these videos, in a workflow. So, the first step, you extract key phrases such as like good sound quality or value for money from the product metadata and reviews, and then in the second step you input these key phrases into an LLM to generate voice scripts, and in the final step you actually use a 3P video creation service provider to add an a human an AI human like presenter to the video to narrate the script with expressions and hand gestures. Now, here we've generated these videos in multiple languages, Arabic, English, and so on, and we've launched them in, like UAE and India and US and so on. And here's just a GenAI based product summary video that's completely automatically created with no manual intervention. Now, again, I don't know why the sound isn't coming through, but I'm just going to show you a little bit of the video. And unfortunately, without the sound, it's a little bit less compelling of an experience. But I'll show you a short clip of the video here that is automatically generated using LLMs, right? And talking about a product. Yeah. Yeah. So this is a video talking avatar that, is talking about the different features, uh, about the battery life, the RAM available, and so on. Some of the key features include fast charging and built-in GPS and so on. Entire voice script generated using uh, LLM. And the LLMs also, we're using them to come up with the layout of the screen, how you show the text and images, and what are the appropriate images to show for when you're talking about every feature of the phone. Finding the most relevant image to show is also kind of something that's determined using LLMs. So, it's a fairly complex workflow because you have to take the product images, match them with the right features. You've got to summarize the features. You don't want too much text. You have to generate the voice script. I think one of the biggest challenges in the talking avatar was getting the lip sync right, with the avatar speaking and their lips moving. We've also used GenAI techniques to generate videos of a product in a different color. So here we have a video of a model wearing a gray shirt, and we can use LLMs to change the color of the shirt in the video from gray to pink, which is the color in the reference image, right? And one of the benefits of this is that we don't really need to record multiple videos of the model wearing different colored shirts, which is again becomes very expensive. Instead, we can just record a single video of the model and then use Gen AI techniques to generate multiple videos of the model wearing different colored shirts. We can also, extract a motion from an existing video and then superimpose it on onto an image of a model to kind of create a video. So, I mean, this is technology that allows us to kind of create videos out of images, right? So, all I need is an image of a model, and then I can take the video from I can take a motion out of a different, of a video, and then, kind of combine the two to kind of generate videos. Again, this is also a way of reducing the cost of generating these videos, 12 videos of models kind of showing what a, dress looks like from different angles or turning around and so on. We've received feedback from customers that they find our product images with white backgrounds to be, boring and lacking visual appeal. So we have come up with stable diffusion techniques to change the background from white to neutral tone. And you can see here, our stable diffusion techniques generate fairly realistic images with shadows and so on captured in the image. They also, can uh, capture the separation between the floor and the wall here, which kind of makes the images look a lot more realistic. Um, and here you can also see that the backgrounds in these images are complementary to the product image, right? So um, pretty interesting, and we've seen again improvement in conversions as a result of changing the background of the images. We see that customers have been purchasing a lot more products, when these images are more engaging with neutral tone background colors and so on. We have also been using Gen AI techniques to fix defects in images, right? So one of the things is, having text in images is considered a defect, and you can see that there's some text in these images on the left hand side of the arrows, and using Gen AI techniques, we're able to uh, identify the regions where the text is, and then do in painting over them to kind of remove recreate the image without the text. And now, I want to take 10, 15 minutes just to talk about some best practices uh, to build LLM applications. And, there are four of these here. The
Rajiv, would
first,
you like to
yeah, go
take
ahead.
a question?
Yeah, sure. Okay, go ahead. Yeah.
So there are a couple of questions. There are some which are related to a specific project, so I'll keep that to the end. One question was, did you use only LLM or also RAG models? I think you're going to talk about that. So
Yeah,
maybe you can skip answering that for now and
yeah.
answer it when you get to it. The other question was related to, how do you ensure that the temperature of LLM satisfies what is needed by us?
I see. I mean, this is in terms of the temperature parameter of LLM.
The accuracy of LLM, I guess.
Yeah, I mean, again, I think it's a hyperparameter that you have to tune, right, based on what temperature kind of gets you the best, uh, the most accurate answers using cross validation and so on, right? Yeah, I think that would be my response there. Why don't I just talk a little bit about the best practices, and then maybe
Okay,
we can take more questions at the end, because I think many of the questions may even get answered as I talk about some of the best
sounds good.
practices here.
Sounds good.
So, hallucination is clearly a problem. This is the phenomenon when LLMs give plausible sounding but incorrect or stale responses. And to tackle hallucination, one of the very effective technique is retrieval augmented generation, where you generate responses to user questions based on relevant context that you've retrieved from a knowledge store. Here, our troubleshooting chatbot that I talked about before has this knowledge store containing troubleshooting guides, product usage manuals, product descriptions, customer reviews, and so on. So you can see here the customer has this question: my phone is overheating during calls. What do I do? You kind of retrieve, our troubleshooting chatbot retrieves this relevant context from the knowledge store to answer the user question. Here, this is a solution for that specific issue that's obtained from a brand website, right? And now, as you can see here, the question plus relevant context are input into the LLM to kind of generate the steps to resolve the issue, right? So you can see, like, on the right hand side, the response has uh, some of the steps for resolving the issue. Now, so RAG basically helps you to give answers that are fresh, precise, and less prone to hallucination, right? So this is a very powerful technique to resolve hallucination issues in LLMs. Self reflection is something that I talked about earlier, also, right? So, or self verification, having the LLM itself verify its response is another very powerful technique to handle hallucination that we use. And of course, I mean, another technique is related to the temperature question that was asked, which is, you can allow the LLM sample a number of responses from the LLM, and then see whether there is consensus amongst those responses, right? And you can detect hallucination in that way. So if the different samples have a lot of variance in them, then probably there is, a lot of uncertainty in the response, right? And if your answers are matching the different samples that you pick out of the LLM, then it's less likely to be hallucination. Another interesting thing with the troubleshooting chatbot that we found is, how you store data in your knowledge store, right? I mean, you can just take text blobs and just shove them into the knowledge store, and that's not going to give you the best accuracy, right? So one thing that we found is, you know, curating the data in the knowledge store and structuring it into logical chunks help to improve the accuracy of responses. Specifically, when we organize the data in the knowledge store as issue solution pairs, issues were extracted from sort of customer chat transcripts that we had, and the solutions were extracted from brand websites, and storing the data uh, 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 as solution uh, issue solution pairs were did help to improve the accuracy of responses, right? So it's important to organize the data in your knowledge store also properly when you're using RAG. So I think that's a one of the best practices that I wanted to talk about, just in the context of RAG and knowledge stores and organizing data in the knowledge store and so on. The second prompt best practice is around prompt engineering, and here, clearly, what we found is LLM performance is very sensitive to the choice of input prompts. And here, the objective of prompt engineering is to, design input prompts that result in the optimal LLM performance. And you can see here, right? I mean, by a careful prompt design, you can really get the LLM to generate high quality responses. So here, this is a prompt for Claude, which prefers XML style. We found that the adherence to instructions is much better with Claude if you structure your prompt using XML. So then, that's you want to you depending on each LLM has its own, preference for how the input should be formatted. So you want to follow that. For Claude, using XML style gives better performance. The role tag is important. You want to specify to the LLM the role that that it's playing, and it pretty much sets the tone and style for the LLM responses. And then you have the rule sections where you actually, give instructions to the LLM. So you can see here, like, we are telling the LLM, answer questions using only the provided context. Don't recommend solutions. And this is for the troubleshooting chatbot. You don't want to keep recommending solutions to the customer that they have already tried. And then, don't provide solutions. You can see the safeguarding rules is, don't provide solutions that can injure the customers, right? Or damage the product and void its warranty. So, there are other instructions you can provide to the LLM, right? As shown here, to ensure that it generates precise and safe responses. Uh, this is a super powerful strategy to improve LLM performance, uh, which is in context examples, right? Including a diverse set of in context examples that are relevant to the input question, adding those to the prompt. We have also, we've seen that has helped to improve accuracy of the responses. And what the example section does is it provides examples of responses for question context pairs that the LLM can actually learn from, right? So you're trying to show the LLM how it can frame the response, in this case, for the issue of sound coming from only one side of the headphones, right? And how it can find the solution for that in the relevant context that's retrieved from the knowledge store. So in this case, the context contains multiple options to solve the problem. And there is one option here that involves resetting the headphones. And you can see the response section here on the slide selects resetting the headphones as the most relevant option to show to the customer, um, uh, along with the step-by-step instructions, right? And here, even though this example is really for headphone issues, the LLM can generalize this prompt, right? This example to issues for other categories as well, right? But it's important to try and include a small number of examples that are diverse and relevant to the user question. That's when you're going to get the best uh, uh, best performance, right? Improvement in performance. And in context examples have definitely, even a few in context examples can make a big difference in performance and give a big jump in performance. And finally, there's chain of thought. You want to try and enhance the reasoning capabilities of LLMs. Uh, and you can use the same prompt as before, but chain of thought is what's added to it. And for Claude, chain of thought is like captured in the thinking sections, where you really go through these intermediate steps involved, the reasoning steps involved in generating the response, and you show these to the LLM so that it can follow those same steps when it's generating responses for a user question context pair, right? So for example, here you can see the chain of thought that we've added to the in context example, right? The previous in context example is how do you generate the response from the user question and the context. So here we're saying, find once you've got the context, find those chunks that are actually relevant to the product issue. Then you group the chunks based on their relatedness. And so here you can see there are three groups: one involving resetting of headphones, something on charging your device, and so on. And then you know find the most relevant solution that has not yet been tried out by the customer, and then generate fine grained steps based on the information in the cited chunks in an easy to follow sequence, right? So this is sort of rather than just giving the LLM the question and context and the final response, if you can even explain to the LLM in the example, how did we actually come to the response from the inputs, right? uh, that again helps the LLM kind of generalize that to other user question context pairs, and come up with the appropriate response following the same reasoning steps that you've provided for the examples, right, in the prompt. So this is again a very powerful technique to kind of improve the LLM performance, and is being used a lot in a lot of these reasoning models that are being launched by OpenAI, DeepSeek, and so on. You can see here, we've kind of put down the precision and recall of the responses to questions using context. This part here without LLMs is when we just use the context as the response, right? The retrieved relevant context from the knowledge store, which is returned, without any processing by LLMs. And you can see that once we use LLMs to generate the response using the user question and the retrieved context, there's a big jump here in precision and recall, right? 1,000 bips in precision, almost 1,500 bips in recall. And then you can see with RAG, we get again a jump in precision and recall, and then a further jump in precision and precision here with using in context examples, and then finally adding chain of thought again gives us a big jump, right? Again, this is for our application. The performance can vary, is very application dependent, but clearly, I think these are all starting with using LLMs, adding RAG, adding in context examples, and chain of thought, all can help give improvements in performance. I don't know if I have a lot of time, but I also wanted to talk a little bit about prompt engineering, automated prompt engineering, and I'll go through these slides real quick. I mean, manually writing prompts can be tedious, right? And there are a lot of tools out there. There's LMOps, there's DSPy, and so on. So you want to try out these tools to kind of come out with automatically come up with better prompts, right? And these tools, in fact, they use LLMs to generate better prompts, and they operate in four steps. And I'm going to go really quick. The first step is inference, where they actually use the current prompt and the user question are both fed into the LLM to kind of generate the response. And then there's a following step there, which is an auto evaluation step, where you use LLMs to find out which responses are incorrect, which where the responses don't semantically match the ground truth, right? So identify where your LLM, which examples. So, all these tools require a validation set where you provide the question and the ground truth response, right? So you provide a bunch of those in the validation set, and then you identify which are those questions where the LLM response isn't quite matching the ground truth, right? Now that those are the problem areas. And so then in the third step, you identify the reason why the why is the response and the ground truth, LLM response and the ground truth not semantically matching? What's the reason, right here? And that kind of serves as a gradient, which you again, you take all those reasons for incorrect responses, you take the current prompt and you input them into another LLM and say, generate a new prompt now that tries to fix all these reasons for incorrect responses, right? So that's and then you generate a new prompt, and that becomes the current prompt, right? And then again you repeat the steps, repeat these iteratively until the number of incorrect responses that the LLM is generating really go below a certain threshold, right? So I think using automated prompt engineering tools is also a good practice that you should definitely try. We have seen in many of our applications, tools like DSPy have really given us step improvements in performance for some applications. And of course, I mean, you also want to use, I think a third best practice, it had come up earlier, use LLMs to evaluate model performance, right? I mean, evaluation of these subjective answers to queries, using traditional text evaluation metrics like Rouge, can be error prone because they don't really capture semantics, right? And using human auditors can be too expensive. These LLMs perform as good as humans in a lot of these text understanding tasks. So, you can use LLMs to actually automatically evaluate model performance. The final best practice I would say is, these large models like Claude, they have higher accuracy for complex tasks, but they are also computationally more expensive and also have higher latency, right? So what you want to do is maybe you have simpler high frequency tasks, right? For example, maybe like step one here, determining an issue like phone overheating. Here you can use a small model, and that can be Mixtral or something, right? And then for the more complex tasks, right? For example, generating the final response in step three here, which are less frequent, you can use Claude, right? And this can help application developers reduce the overall latency and computation cost of building LLM solutions. So with that, I'll just, here's a summary. Again, I talked a little bit about the trends on agentic computing. I think is a big one. I talked about some applications we've developed and also best practices like using RAG, auto prompt engineering, auto evaluation, and then use smaller LLMs for simpler tasks. So there are 5 minutes remaining. I'll be happy to take questions. Yeah.
All right. Thanks, Rajiv. So there are a couple of questions I'll quickly read. Uh, can we get some beginner tools used to build LLM? That's one. And the second part to that is also how many categories of team work on LLM? I think it's more to understand how large your team is or how your team is structured. Maybe that's the question.
Yeah, I mean, look, I mean, all the big cloud service providers have a ton of tools for using LLMs. they host a lot of these LLMs like Claude and Mixtral and Llama and so on. Amazon has Bedrock. I'm sure Microsoft and Google Cloud also have these tools. I think you should be using those tools. Also, like I talked about, open source tools for prompt engineering, like DSPy and so on, right? And within Amazon, we are using LLMs uh, across the board, right? Everywhere, we are using LLMs to get more efficiency, more productivity, and so on. I gave some samples, but like customer support is another area. Yeah.
There's a slightly different question, not quite related to the talk, but I'll just ask the question
Sure.
and see if you can answer this.
Yeah.
This is regarding a team that is working on Marathi, creating Marathi sentences in Marathi language as part of their final year project, and they are using contextual embeddings of IndicBird or Mural or decoder based modules, and asking you for suggestions on which approach will be best for this. And do you see any deficiency in Marathi language, online data available for Marathi language? And it's a long
Yeah. I
question. Yeah.
I look again. I haven't played around with Marathi and Indian languages, so but I know that Claude and a lot of these models are doing a pretty good job on. Like I showed you English, right? Like Claude does a great job with English, and even though perhaps I don't know how much data on English is out there, and so Hindi also I hear like many of these models are doing quite well. So I think you should look at some of these models like Llama and Mixtral and Claude and ChatGPT. I think they're doing pretty decent
I think
for
the context was more around, ambiguous words, right? So how do we, I mean, the word in a different context would have different meaning. So do you
oh,
have any suggestions on
ah,
that?
yeah, I mean, again, I mean, you've got to, I mean, contextual embeddings, but BERT does that pretty well, right? So you've got to use techniques like BERT, train it on a Marathi corpus or fine-tune BERT on a Marathi corpus, and then get contextual embeddings, right? I mean, that was the big contribution of BERT, which was to really generate embeddings based on the context here.
Uh, One student has asked if you can recommend any books and papers for students who are, who want to get into this area. Are there any good books or papers that you would recommend?
Uh, I mean, there is Karpati, and I can't remember his first name, but he has
Andre.
Andre Karpati. I mean, I myself like learn a lot watching videos of his lectures and so on, right? So a lot of people on the web, there's a lot of context on the web, on the internet. Like definitely Andre Karpati is one person that would be worth following. I think he's very passionate about education. He's got fantastic videos on explaining how LLMs are trained and all the tricks, and I find them educational, right, at my level. So at least that's one name that comes to mind. I mean, uh, I'm sure there's lots of resources out there. If you follow Andre Karpati, maybe you'll get pointers to more good resources to educate yourself on LLM.
Uh, the next question is, can you suggest any LLM module suitable for legal assistance prediction?
And by the way, also the papers on Llama, I mean, they have like white papers on Llama, like how Llama's built. There's white papers on all these. DeepSeek has a technical memorandum. So all these models have like on archive, white papers, technical white papers that again are very educational, right? Like Llama is a very detailed white paper on audio and audio supported and things like that. And I think those are good resources. DeepSeek, I haven't gotten a time to read the DeepSeek TM. Is on my list of things to read. But I mean, that's the best way of educating yourself. Read up on, Quen is another very leading model from Alibaba. Just search on Google, Quen technical reports or yeah, and you'll get like pointers to archive papers describing details about these models, right? How they're built, and those can be very educational. Yeah.
There are two questions on legal, so maybe this would be the last question. We are already at the top of the hour. So this is regarding LLM models for in the context of legal assistance prediction, especially finding loopholes in legal contracts. Do you have any suggestions or recommendations on that?
I mean, it can be definitely. I mean, we are using LLM for legal, like compliance issues, right? I mean, we want to know, well, if there is a certain products that we want to import into a country, how does it work? Are there any things from a legal standpoint that we need to be aware of, right? And there's all legal guidelines, right? Countries say we won't allow imports of these sorts of products. These products, they're only going to allow so many. We can input. You can input all the laws,
Mhm.
legal documents, right, into the LLM knowledge store as RAG, right? And then you can just be asking questions to the LLM, like what products can I import or blah blah blah, right? So you
I
could
think the question was more related to are there any specific LLMs that are in the context of legal would have better
uh
outcomes for legal? I mean, are you aware of any or
I don't
in the
know. I
general
know
context?
Sarvam AI is focused on the legal vertical. I know they're building something for the legal space in India. I don't
Okay.
know details about it. I was told that legal is one area they're focusing on, but I think even you can build your own. I think Claude and others, we found them doing really well in terms of reasoning with legal, legal content uploaded in RAG, right?
Right.
And retrieving those. So basically what I'm saying is even those publicly available foundational models that have not been fine-tuned for legal applications actually do well. But of course, you still need to retrieve the right content from RAG. All that will need to be implemented. But I think Sarvam AI may be something to look at. Maybe they've
Sure.
done,
Okay.
uploaded, they've got put embeddings and they've already done the RAG stuff. So they've done all that heavy lifting for you. So all you need, you can just use it out of the box for Indian legal stuff, right? So I think look at Sarvam. At least that's one company I know that's been focused on the legal space in India.
Great. Hey, thanks, Rajiv. We are at the top of the hour. So, let me take this opportunity first. Thank you for a wonderful session, enlightening all of us on the good practices, especially. And also, as Amazon users, many of us are also experiencing the value that you and your team have been able to add to the overall user experience, the seller experience, as well as the quality of the products, the catalogs that are displayed. So, thank you for sharing your thoughts on this. And I'm sure we have all learned a lot today. And we look forward to many more
Thank
such
you.
interactive sessions going forward. Thank you very much,
Thanks.
Rajiv.
Thank you. Thank you.
Thanks for inviting me. Super exciting space, and look forward to more talks, uh, Venki, on from ACM India on this topic. Thanks.
Thank you.
You.
Bye bye.
Oops.